Before I can do the calculus, we're going to go through a little algebra 2 first. Your end goal is going to be to find the derivative of inverse functions. So we're back to derivatives. The good thing about this section is it does go quickly. You don't have to show a whole lot of work. On a test, I can only really make it worth 1 point. And they're usually multiple choice. So this is not, like, I would put this in the bottom 5 of all stuff we do all year. 5-2 I put in the top 5. This is in the bottom 5. This is not super important. It won't affect your test score much. It won't affect your AP score. They put one multiple choice one on there every year. Kids do terrible on it, but it's 1 point, so it's not a huge deal. So we're going to first go back and do a little bit of algebra 2 with our inverse functions, just to make sure you understand properties of them first. So a function only has an inverse if it's 1 to 1. What that means is for every x there's one y, and for every y there's one x. Graphically, it means it passes 2 tests. What's one of them? Vertical line. What do you think the other one is? Horizontal. Yeah, it has to pass both the vertical and the horizontal line test for it to have an inverse. So for example, y equals x squared as it is does not have an inverse because for every y there's actually 2 x's that get mapped to it. But if I restrict its domain, then it has an inverse. So sometimes we just do a piece of a function in order to get it to have an inverse. Same thing, the sine wave as is doesn't have an inverse because it fails miserably the horizontal line test. But if we just restrict it from negative pi over 2 to pi over 2, then it looks like that through there. So you'll restrict its domain. Inverses undo each other, like the square root of x squared is just x. So we're going to go view them in 3 different formats. With points, an inverse is easy, and you maybe saw this in Algebra 1. All an inverse does with points is swap out the x's and the y's. It just inverts them. It's kind of the name. So when you're given a set of points, its inverse function just swaps the x's with the y's. Are you going to do that today? No. But it's important to know that this point on the original and this point on the inverse swap out. Those are called corresponding points, and that's super important. You're going to have to find a pair of corresponding points. So if you know 3, 8 is on the inverse, the original had to have 8, 3. That's going to be important for you. I won't, though, have you write this out. That's just for you to see that. Letter B, in Algebra 2, you were taught how to find inverses. They probably told you, well, make sure you label it as y first. Do you remember what they told you to do to find an inverse algebraically? Swap them out. And this you might see on an ACT test. You won't see it on my test. This is Algebra 2. Just swap out, just like you do here, the x's and the y's swap. Then what were you told to do? Solve for y. Yep. And you would end up doing the opposite operations. Where 8 was subtracted, you would add it. Where 5 was being multiplied, you would divide it. So you can see that you actually undo the operations of f to get the function for f inverse. Makes sense. What's more important about this, though, I'm not going to have you do this. That's not the calculus part of it. This has nothing to do with calculus yet. However, you're going to be looking at derivatives. And a derivative is a what? What's a derivative formally? Slope of a tangent line. So watch. Here's my original. What's its slope? 5. Here's my inverse. What's its slope? 1/5. What's the relationship between my function's derivative and its inverse's derivative? Reciprocals. That's important. So there's 2 things off these 2 that are important. Corresponding points exist on functions and their inverses. Their slopes on a function and their inverses are reciprocals. That's super important. Graphically, what happens with a function is that it swaps out the x's and the y's. So 1, 1 would remain 1, 1. It gets mapped to itself on an inverse operation. But 3, 2 would go to 2, 3. 4, 4, it looks like, is going to stay put. But basically, the inverse function reflects over this line. Oh, that's a really bad graph. I apologize, but I don't want to erase it. What line do inverse functions reflect over? Y equals X. It makes sense. It's what we did over here. This one's Y is this one's X. What did I do here? I replaced Y with X. What's happening graphically reflects over the line Y equals X. That's all Algebra 2. No calculus yet, but 3 important concepts. We have corresponding points, we have reciprocal derivatives, and we have graphs that reflect. All right, so down here in the next part is noting that the domain of one function is the range of another. This is important. Sometimes with the notation, it gets a little murky. I mean, it's awkward to write f inverses derivative at x. It's got like all those little, the negative, the one, the prime. So a lot of times they'll just redefine it and they'll tell you your inverse function, we're going to call it g. So watch for renaming of things because they do that for ease in writing it. I already talked to you about corresponding points on the function and its inverses, just swapping out x and y. So that's nothing new. Haven't done any calculus yet. I'm getting there. All right. So on the next page, they're going to disguise some of the language, so it might not actually say the functions are inverses. They might give you this, and you have to infer, all right, if they're telling me that, they're telling me that f and g are inverses. They are undoing each other forwards and backwards. That's what they are saying with that. So if you're doing your worksheet today, let's go look at one on your worksheet where it's disguised that way. If you look at number, where is one? Oh, there it is. Even number 2. Look at it right on the front page. It says W of V of X equals V of W of X. It actually should also say equals X. They undo each other. What am I telling you about W and V? They're inverses. So sometimes the language will get disguised with notation, so you have to just take care of that. That makes sense though. Here's what I want you to be super aware of, and I'm going to say it a bunch of times. So if you have a function and its inverse, yes, they reflect over this line, but we actually won't graph any. I'm going to graph one to show you something, but then you won't choose to graph. It's noticing what happens with the slopes. And if you noticed, the inverse function at a corresponding point has reciprocal slopes. Inverse functions at corresponding points have reciprocal slopes. Inverse functions at corresponding points have reciprocal slopes. I just said the same thing 3 times. That's what you're going to remember today. There's some formulas on the next page that I'm not even going to explain. I'm going to cross them off because I want you on here. This is how you're going to approach them. So I want you to write approach. The first years I taught this, I gave the formulas and it was a train wreck. Then I went to giving the formulas in a more broad approach and it was better, but people were mixing them. So I've since gone to saying I'm not even going to talk about the formula. If you want to figure it out, go ahead. I'm going to give you an approach. Here's what your approach is going to be. It's going to tell you something like this. F of g of x equals x, which equals g of f of x. That's the worst case scenario. Pretend that looks good. Actually, it looks okay. What am I telling you right there? They're inverses. It might actually say they're inverses. I'm doing worst case scenario. And then it's going to say, find g prime, which means the derivative of the inverse function. And they'll tell you an x coordinate. And just for the heck of it, I'm going to make one up. Let's say it says at 4. And that's my end game. You're not going to use a formula to get there. This is how you're going to think it out, and then I'll go show you it working. All right? They're going to give you an x value, so go put an x there. They want you to find the derivative of this function at that x value. Sometimes it looks like this, the derivative of this function when x equals 4. Same stuff, right? So you know that 4 is an x value on g. I'm going to leave that open. So I want you to write 4 comma I don't know is on g. That's what you know. They handed you an x value on g. You don't know what the y value is. So that's your first thing. Get the x on the function in question. What that will allow you to do is know the y value on which function? on F in this scenario. Now, if they call them W and Q, you have to work with that. That's why I'm not giving you the formula so that you can handle variable changes. That must be on F. All right, so they will hand you an X. You automatically will know it's a Y in the corresponding point. That makes sense, correct? Because functions and inverses, you just swap the X's with the Y's. You will be able to find this. I'm going to have you point an arrow. You will be able to find the X coordinate, and it won't be difficult. It'll either be on a table, or it'll be handed to you directly, or it'll be super easy to find. I'll do all three scenarios in a minute, but you're going to easily be able to figure out what this is. Let's pretend it was 1. That will be really easy, okay? That also gives you this. So your first task is going to be to get the corresponding points. Are you all right with that? Then you're going to be able to find the derivative on the original function. They will either hand it to you, it'll be on a table, or you'll know F, and you'll be able to take the derivative. And let's suppose you get negative 2/3. That'll be easy, trust me, that'll be easy to find. And then I'm going to repeat that phrase. Inverse functions at corresponding points have reciprocal slopes. So G prime of 4 will be the reciprocal of F prime at 1. At corresponding points, they have reciprocal slopes. So what would my answer be? Negative 3/2. Okay? And that will be my answer. Now, these were generic. I didn't do any examples. I'll do that in a second. It's going to be like a puzzle. They liked this last hour. I'm going to immediately cross that formula off because it's going to screw you up. Trust me. It took me 3 years to figure out it was the formula that was messing everybody up, because then they call it like W and V, and kids are like, I only have the formula memorized for F and G, and it really caused a problem. So we're not going to use any formulas. But what I am going to do is demonstrate it graphically so you can see the process. Here you go. I'm going to call this, instead of Y, we're going to call it F of X. And actually, in order for it to have an inverse, I better give a little domain restriction on that as well. So we're going to look at the right-hand lobe of our parabola function. Let's go do that. And I'm going to do this really slow. If you can understand this, it'll make the worksheet just seem easier. We're not going to graph. We're not even going to find derivatives, but I'll show you it graphically. So I'm going to go graph y equals x squared. It goes through 0, 0. It goes through 1, 1. It goes through 2, 4. And it goes through 3, 9. And I'll draw that. I'm even going to, let's label some of these points. Well, let's label this one 2, 4. And let's label this one 9, 3. I'll let you catch up. All right. Oh, sorry. I was thinking of the reciprocal function already, or the inverse function, 3, 9. All right. Next, I'm going to deal with a function that's called G. I'm going to rename it because I don't like writing F inverse derivative, but I'll tell you that G is F's inverse. I gave you a function that's really easy to see what the inverse is, right? What's the inverse of x squared? Root x. Yeah. So graphically, I'll show you this process working. Go like that. And let's draw it. Head out like this. Let's put the corresponding points on it as also. If 2, 4 is on F, 4, 2 is on G or F inverse. If 3, 9 is on F, then 9, 3 is on F inverse. So there you go. This is the function f of x. This is the function g, which is really F inverse. So far, so good. Your task is going to be to find the derivative on the inverse function at a specific point. Let's pick this one, so underline that. I'll write it with notation. It will say find G prime of 9. That's what it'll say, and that's your end goal. And you might say, but Larude, I already know the function, so why don't I just take the derivative and you won't know. I'm showing you graphically it confirming the process. Here's the process, all right? And then you won't know what the functions are. This is for demonstration purposes. So watch. Here's your process. This is an x value on G. I am looking for the derivative there. So let's draw the slope of the tangent line. I'm looking for that. All right, so here's the process. 9 comma something is on G. That will be your first process. Then you're going to say, well, that means something comma 9 is on F. And you can see it because I graphed it, but you won't have a graph and you won't be able to see it. But who's my something? Obviously. 3. Okay, you will find those. It'll be very easy. It'll probably be handed to you more than half the time. So there's your corresponding points. That's your first process. Get the pair of corresponding points. Then you're going to find the derivative on F. You're going to find F prime of 3. It'll be easy, just like on this one. If F is x squared, what's F prime? 2x, right? So what's F prime of 3? Basically, I'm asking you, what's the slope of this tangent line here? F prime of 3 is going to be what? 6. Yeah, if f is x squared, its derivative is twice x. At 3, that would be 6. According to what I told you, the inverse function's derivatives are reciprocals. So your answer is really 1/6. Let's verify it. This is the process giving you 1/6. We found a corresponding point. We found the derivative there. We flipped it over. That's going to be your process today. I'm going to repeat it. You're going to find your points. You're going to find your derivative. And then you're going to do what? Flip it over. Did it work? We know that we could have done this with the math because we could see the functions. Let's go find g prime. What's the derivative of x to the 1/2? That's one we have memorized. What is it? 1 over 2 root x, right? It's 1/2 x, boom. My goal was to find that at 9. Did I get the 1/6? Is it verified, right? So what we're going to do now is take away the graph, take away the names of the functions, and see if you can follow the process. This will mess you up. I need to take it out of the notes. We're going to take this whole page and just chuck it. This is where we're going to go. We're going to do 3 examples. All right, 3 all that have different information, but you're going to follow the process. You're not going to use a formula. You're going to understand what you're doing, and you're just going to say, okay, I need to get a pair of points. I'm going to find the derivative, and then I'm going to flip it over. So let's start. I'm given the function for f. Okay, it's said to find f of 0. Well, let's do that. F of 0 is what? 2. Okay, I must need that at some point. Now it says to find f inverse's derivative at 2. So I want you to go like that. They're giving me an x value on f inverse, and you're going to write that. You're going to get your points. You're going to go 2 comma I don't know is on f inverse. They will always hand you that x value of the point. And you're going to say, well, the corresponding point, something comma 2, is on what? F. And you're going to write that. It's going to help you get the points. And then you'll, like I said, you're going to go find this. It'll either be handed to you or very easy. Something comma 2 is on F. 0. It's right there. So you're going to get your corresponding points. There, that's phase 1. Get your points. Whatever information you have, get the 2 points. Then find the derivative on the original function. You'll be able to do that. You'll either do it off a table, they'll hand it to you, or you're going to have to do it manually. On this one, for me to get the derivative, I better take the derivative. But it's an easy derivative, right? Go ahead, Jess, and tell me what the derivative of f would be.
2x to the 4th plus x squared plus 3.
Okay, that's an easy derivative. And I'm supposed to find it at 0. I could do that in my head probably too, but I'm writing it all out just so you have something to look at. What's the derivative at 0? 3. All right, so I just found the derivative at 0. It's 3. So the inverse's derivative at corresponding point is going to be what? 1/3. And I'm done. So my answer is 1/3. I'm going to repeat the process. We did not memorize a formula. This is what we're doing. With whatever information given, what do I find first? The points. You'll be able to easily do that. Trust me. There's only one on your worksheet that they were like, whoa, and it's because I purposely messed with the notation. We'll talk about that when I get to the worksheet. So watch, this next one says sometimes we're just handed everything. You just need to understand these have horrible statistics on the AP exam because kids look at this and go, I have no clue what it's asking me for. Doesn't that look confusing? But let's sort it out, because once you sort it out, you can do it in your head. Here we go. This is really telling you what? We have inverse functions. All right. And then they give you a point and a slope, super, and they say to find this. All right. And if you memorized a formula, you get screwed up because what does the formula have in it? F's and G's, and that because then kids are like, is the N, the F, or the G? It doesn't matter. You're not going to use the formula. You're going to say they handed me an X coordinate, and you're going to go put it there on N. And they want me to find the derivative there, but there's got to be a point there in order for me to find the derivative there. So you're going to start that like this. And then you're going to go and put its corresponding point on the other function. You can call it N inverse or M. It doesn't matter. They're the same thing. Then you have to fill in this slot. I told you, you'll easily be able to find that. They'll hand it to you. It'll be on a table. Or on the last one, I had to go actually take a derivative, right? Or actually go work with the function. This one, it handed it to me in a bowl. Like, here you go. Dump it in your problem. What goes in where that arrow's pointing? 5. They handed me 5, -9. And that gives me my corresponding points. Check. That's the first thing. After you get your corresponding points, do you remember what you do? We're not memorizing a formula. We're kind of picturing me graphing it. I've got my pair of points. And now I find what? The derivative first. On which function? The original. Yeah, it's always going to be the bottom one. You're going to find what the derivative is at 5. Because its inverse function will have a reciprocal derivative. I just showed it to you with the 6 and the 1/6. Mathematically, it will always work out. Did they give me that, or do I have to go find it like I did on the first one? They handed it to me in a pre-measured bowl. They told me what it was. That's not my answer. My answer is the what? The reciprocal. Exactly. The inverse function's derivative at its corresponding x value is the reciprocal. It's like a puzzle, but I'm giving you a very good algorithm for solving the puzzle. It works on all of them. So let's again repeat. Now I'm messing with you again. I didn't give you a function. I didn't hand you stuff in pre-measured bowls. What did I give you? A table, and that table has a lot of extra stuff on it. So you have to find what you need off the table. Let's go do that. Same process. Here we go. What am I being told? Inverses. Here's the x value on G. I'm going to find the derivative there eventually. Before I can do that, I'm going to go to its corresponding point on what? F. I always need to supply that. They handed it to me in the one above. In example number 4 at the top, I had to actually go find it from the function. On this one, I need to find it from the table. What got mapped to -3 on F? Basically, I'm saying F of what is -3? 7. I can see it on the table, right? Here's this one. Where is there a -3 on F? Right there. 7, 7. Check. Corresponding points. Now let's see if you've got the algorithm down. Once I have my points, what do? I find the derivative on the original. Yeah, I'll be able to get that off a table, or they'll hand it to me, or I'll go to the function and derive it. But I need to find the derivative at 7. All right. When x is 7, what's f prime of 7 according to this chart? 2. Okay. I don't even really have to do much work, but I just got to suck all this information out. Well, I want to know the inverse's derivative at its corresponding point. What's it going to be? You're going to put it in a box and be done. Because inverse functions at corresponding points have what? Inverse functions at corresponding points have reciprocal derivatives. All right, so is that the last one? No, this one right here is off an actual AP test. I just retyped it. There's always one multiple choice, that's it. If you can't do it, you're going to lose 1 point on your AP test. Will I put this on my test? Yes. I'll tell you, I put 2, but how many points are they worth? 1, maybe 2 if there's one where you have to do a little work, but it can't make or break you. Again, it's the bottom 5 of things you do, but I like the thought process of it. However, it's not a big hitter in here. I'm going to pause this video because I'm done, and I want you to do this one on your own. This one had less than 20% of kids nationwide get it right. It was in the bottom 3 scoring on this one. It was off the 2008 exam, and they publish how many kids get it wrong. And this one had most got it wrong. It was really bad. You go see if you could get it right. I'm done. Homework is worksheet 5.3 if you're not here.